Welcome to Tech with Kaushik. This is set 17 of our DOP-C02 AWS Certified DevOps Engineer Professional Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link in the description. Let us begin set 17. Now for question number 303. This one focuses on organizations and SCPs. Here's what is happening. A company manages multiple AWS accounts using AWS organizations. To improve security posture, the company mandates that all Amazon EC2 instances must use Instance Metadata Service version 2, DSV2. A DevOps engineer needs to enforce this policy centrally across the organization. The solution must ensure that new EC2 instances cannot be launched unless DSV2 is strictly required, and it must also block any AWS API calls made from existing EC2 instances if the credentials were obtained using DSV1. Which combination of SCP statements should the DevOps engineer apply to the organization's root? Here are the options. Choice A. Deny the EC2. Run instances action if the EC2 metadata HTTP tokens condition key is not equal to required. Deny all actions, asterisk, if the EC2 role delivery condition key is numeric less than 2.0. Choice B. Deny the EC2 run instances action if the EC2 metadata HTTP put response hop limit condition key is greater than 1. Deny all actions, asterisk, if the AWS token issue time condition key is null. Choice C. Deny the EC2 run instances action if the EC2 metadata endpoint condition key is enabled. Deny all actions, asterisk, if the EC2 role delivery condition key is string not equals DSV2. Choice D. Deny the EC2 run instances action if the EC2 metadata HTTP tokens condition key is optional. Deny all actions, asterisk, if the AWS multi-factor auth present condition key is false. In this case, choose option A. Deny the EC2 run instances action if the EC2 metadata HTTP tokens condition key is not equal to required. Deny all actions, asterisk, if the EC2 role delivery condition key is numeric less than 2.0. Here's why. Enforcing DSV2 requires two separate controls. First, you must prevent the launch of new instances configured for DSV1. This is achieved by denying EC2 run instances when the EC2 metadata HTTP tokens condition key does not equal required. Second, you must ensure that existing instances cannot use DSV1 credentials to execute API calls. When an EC2 instance assumes an IAM role, AWS records how the credentials were delivered. If delivered via DSV1, the EC2 role delivery condition key is populated with 1.0. If delivered via DSV2, it is 2.0. Denying API calls, asterisk, when EC2 role delivery is less than 2.0 ensures no older DSV1 credentials can be used. B. EC2 metadata HTTP put response hop limit controls network hops for the metadata token, not the requirement for DSV2 itself. AWS token issue time is used for credential age, not IMDS versioning. C. EC2 metadata endpoint controls whether the metadata service is enabled or disabled entirely, not which version is enforced. EC2 role delivery outputs a numeric value, 1.0 or 2.0, so numeric less than is the proper evaluation mechanism. D. EC2 metadata HTTP tokens does not accept optional as a secure restriction value in this context. It defaults to optional. AWS multi-factor auth present is irrelevant to instance metadata credentials. Here's a useful exam tip. To fully lock down an environment to DSV2, use EC2 metadata HTTP tokens equals required to govern instance creation, and EC2 role delivery equals 2.0 to govern credential usage in IAM policies or SCPs. Question number 304. A DevOps team manages a distributed application running on an Amazon EC2 auto-scaling group. The application outputs logs to Amazon CloudWatch logs using the embedded metric format, EMF. The logs include the instance ID field and an error count metric. Recently, a single degraded EC2 instance began failing a high percentage of requests, but it continued passing standard EC2 and application load balancer health checks. The DevOps team wants to receive an Amazon SNS notification automatically if any single EC2 instance becomes responsible for more than 50% of the total application errors across the fleet. Which combination of steps should the DevOps engineer implement to meet these requirements with the least operational overhead? Choose 2. Select all answers that apply. Choices. Option A. Create a CloudWatch contributor insights rule that analyzes the CloudWatch log group. Group the data by instance ID and aggregate the error count. Option B. Configure an AWS Lambda function to aggregate logs every minute. Calculate the error percentage per instance and publish the results as custom CloudWatch metrics. Option C. Create a CloudWatch metric filter that extracts the error count from the log group. Configure a CloudWatch anomaly detection model based on the metric filter. Option D. Create a CloudWatch metric math alarm that calculates 100 * insight_metric. Rule name, max contributor value, /insight_metric. Rule name, sum. Trigger the alarm when the expression is greater than 50 and notify the SNS topic. Option E. Create a CloudWatch alarm based on the custom CloudWatch metrics generated by the Lambda function. Trigger the alarm if the error percentage exceeds 50% and send a notification to an SNS topic. The answers that work here are Option A. Create a CloudWatch contributor insights rule that analyzes the CloudWatch log group. Group the data by instance ID and aggregate the error count. And Option D. Create a CloudWatch metric math alarm that calculates 100 * insight_metric. Rule name, max contributor value, /insight_metric. Rule name, sum. Trigger the alarm when the expression is greater than 50 and notify the SNS topic. This is the best choice because contributor insights can aggregate error count by instance ID and expose rule metrics to CloudWatch metric math. Insight_rule_metric can retrieve max contributor value for the largest per instance contribution and sum for the fleet total. Dividing max contributor value by sum and multiplying by 100 yields the largest instance's percentage of all errors. An alarm on that expression can notify Amazon SNS when it exceeds 50%. Here's why the alternatives are not suitable. B. Writing a custom Lambda function to aggregate logs every minute introduces significant development, maintenance, and operational overhead compared to using native contributor insights. C. CloudWatch anomaly detection establishes baselines for expected metric behavior. It detects abnormal spikes, but does not natively group data by dimensions, like instance ID, to determine percentage contribution across a fleet. E. Relies on the custom Lambda function from Option B, which is not the most operationally efficient approach. Exam tip. Whenever a scenario asks to identify the top N contributors, the highest impacting resource, or percentage share of an event from CloudWatch logs, CloudWatch Contributor Insights is the managed, lowest overhead solution. Question number 305. Let's go. This question takes us into CloudFormation. Scenario. A company uses AWS CloudFormation to deploy and manage its application infrastructure. Recently, a stack update failed because an engineer had manually modified a security group directly in the AWS Management Console, causing configuration drift. A DevOps engineer must implement an automated, low-overhead mechanism that detects CloudFormation stack drift and notifies the DevOps lead when the stack is evaluated as non-compliant. Custom polling code should be avoided. Which solution will meet this requirement with the least operational overhead? Options. Option A. Enable AWS CloudTrail and create an Amazon Event Bridge rule to match AWS API calls that modify resources. Route the matched events to an AWS Lambda function that checks if the resource belongs to a CloudFormation stack, and if so, sends an email via Amazon SNS. Option B. Implement an AWS config managed rule using the CloudFormation_stack_drift_detection_check identifier. Create an Amazon Event Bridge rule that triggers on AWS config in_compliant resource state changes, and configure an Amazon SNS topic as the target to notify the DevOps lead. Option C. Tag all CloudFormation resources with a specific tag. Create a custom AWS config rule using an AWS Lambda function that evaluates changes to tagged resources. If a change originates outside CloudFormation, mark it in_compliant and send an SNS notification. Option D. Create an Amazon Event Bridge rule scheduled to run every hour. Target the rule to an AWS Lambda function that executes the AWS CloudFormation Detect Stack Drift API for all stacks and emails the DevOps lead upon drift detection. The best choice is option B. Implement an AWS config managed rule using the CloudFormation_stack_drift_detection_check identifier. Create an Amazon Event Bridge rule that triggers on AWS config in_compliant resource state changes, and configure an Amazon S topic as the target to notify the DevOps lead. AWS config provides the managed CloudFormation stack drift detection check rule, which runs CloudFormation detect stack drift and marks a stack in_compliant when its drift status is drifted. EventBridge can match the resulting AWS config compliant state change and route it to an SNS topic. The detect stack drift operation can take several minutes, so this is automated drift notification rather than an instantaneous alert on every out-of-band API call. The remaining options can be eliminated because A. Parsing all AWS CloudTrail API calls with a Lambda function to determine if they modify a CloudFormation managed resource is highly complex, prone to error, and requires significant custom development. C. Building a custom AWS config rule using a Lambda function is unnecessary because AWS config already offers a fully managed drift detection rule. D. A scheduled Lambda function that calls detect stack drift duplicates the managed AWS config rule and adds custom code and polling overhead. For CloudFormation drift detection, leverage the AWS config managed rule CloudFormation stack drift detection check paired with EventBridge for automated zero-code alerting. Next, question number 306. A DevOps engineer supports a multi-account environment managed by AWS Control Tower. The company's security team wants to automate the deployment of AWS Control Tower controls to specific organizational units, OUs. The security team requires a solution that utilizes version control. The deployment process must support peer review, traceability, and the ability to roll back changes if a new guardrail causes issues. The security team will manage the guardrails via code in their own dedicated AWS account. Which solution provides the most operationally efficient way to meet these requirements? Option A. Create AWS CloudFormation templates utilizing the AWS Control Tower. Enable control resource for each OU. Store the templates in an AWS code commit repository. Configure an Amazon EventBridge rule to trigger an AWS code build project on commit to deploy the templates. Option B. Create AWS CloudFormation templates utilizing the AWS Control Tower. Enable control resource for each OU. Store the templates in an Amazon S3 bucket. Configure an AWS Lambda function to trigger on S3 put object events to execute the CloudFormation deployments. Option C. Create AWS CloudFormation templates utilizing the AWS Control Tower. Enable control resource for each OU. Store the templates in an AWS code commit repository. Configure an AWS code pipeline that is automatically triggered by an Amazon EventBridge rule on code commit repository changes to deploy the templates. Option D. Create an AWS Service Catalog portfolio containing AWS CloudFormation templates for the guardrails. Share the portfolio with the management account. Require the security team to manually provision the Service Catalog products when a new guardrail is approved. Go with option C. Create AWS CloudFormation templates utilizing the AWS Control Tower. Enable control resource for each OU. Store the templates in an AWS code commit repository. Configure an AWS code pipeline that is automatically triggered by an Amazon EventBridge rule on code commit repository changes to deploy the templates. The main reason is AWS CloudFormation supports enabling AWS Control Tower controls with the AWS Control Tower. Enable control resource. Storing the templates in a source repository provides version history and peer review workflows, while Code Pipeline provides a managed deployment path with traceable executions and CloudFormation rollback behavior. Among the options, the Code Commit plus Code Pipeline design best satisfies version control, reviewability, repeatable deployment, and rollback requirements with low operational overhead. Now let's rule out the other options. A. While Code Build can deploy templates, relying on Code Build directly from EventBridge lacks the pipeline structure, stages, visual tracking, easy rollbacks, manual approvals that code pipeline provides, decreasing operational efficiency for lifecycle management. B. S3 put object events triggering Lambda to deploy CloudFormation requires managing custom deployment logic in Lambda, which increases operational overhead compared to a managed pipeline. D. Service catalog requires manual provisioning by the security team for every change, failing the requirement for an automated, version-controlled deployment pipeline. Keep this point in mind for the exam. For infrastructure governance, changes managed as code, prefer a version-controlled CI/CD pipeline. For AWS Control Tower controls in CloudFormation, use AWS Control Tower, enabled control. Question number 307. We're moving on to CloudWatch alarms. Scenario. A company runs a customer-facing application distributed by Amazon CloudFront. The company has enabled AWS WAF and configured it to log to an Amazon CloudWatch Logs log group named AWS WAF Logs. A DevOps engineer needs to set up an alert that triggers if there is an unexpected spike in block traffic. The security team frequently tunes WAF rules, so a static threshold will not work effectively over time. The alert should only trigger for unusual changes in blocked requests and should ignore fluctuations in allowed traffic. The DevOps engineer has an existing Amazon SNS topic for alerts. Which solution meets these requirements? Choices. Option A. Create a CloudWatch Logs metric filter on the AWS WAF Logs log group to extract blocked requests and publish a custom metric. Enable CloudWatch anomaly detection on the custom metric. Create a CloudWatch alarm based on the anomaly detection band and configure it to notify the SNS topic. Option B. Enable a CloudWatch anomaly detector directly on the AWS WAF Logs log group. Create a CloudWatch alarm using the log anomaly priority metric with a medium setting. Configure the alarm to trigger if the sum of anomalies over 1 hour exceeds an expected value and notify the SNS topic. Option C. Create a CloudWatch Logs metric filter on the AWS WAF Logs log group to extract all requests and publish a custom metric. Create a CloudWatch alarm using a math expression that calculates the standard deviation of requests. Configure the alarm to notify the SNS topic. Option D. Stream the AWS WAF logs to Amazon OpenSearch service. Configure an OpenSearch anomaly detection job targeting blocked requests. Configure an OpenSearch monitor to evaluate the anomaly grade and send an alert to the SNS topic via an OpenSearch webhook. The right response is option A. Create a CloudWatch Logs metric filter on the AWS WAF Logs log group to extract blocked requests and publish a custom metric. Enable CloudWatch anomaly detection on the custom metric. Create a CloudWatch alarm based on the anomaly detection band and configure it to notify the SNS topic. Let's look at the reasoning. The company needs to monitor only blocked traffic for sudden changes, independent of overall allowed traffic. First, a CloudWatch Logs metric filter is required to parse the WAF logs and generate a custom metric representing solely the blocked requests. Second, because WAF rules are frequently tuned, static thresholds will cause false positives or negatives. CloudWatch anomaly detection applies machine learning to adapt to the metric's natural baselines and seasonal trends, alerting only when the traffic deviates significantly from expected behavior. The other choices do not work because B. Enabling a CloudWatch anomaly detector directly on the log group, log anomaly detection, analyzes log patterns and structures for application errors, but it does not evaluate the volumetric rate of a specific data subset, like blocked requests, as effectively as a metric filter paired with metric anomaly detection. Furthermore, it might alert on other WAF log changes, violating the prompt's constraints. C. A static math expression calculating standard deviation is rigid and lacks the machine learning adaptability of CloudWatch anomaly detection to handle seasonal or gradual traffic changes. D. While OpenSearch can perform anomaly detection, setting up, managing, and paying for an OpenSearch cluster just to trigger an alarm introduces massive, unnecessary operational overhead compared to native CloudWatch features. The main takeaway is when you need to dynamically alert on unexpected spikes or drops in a specific subset of log data, avoiding static thresholds, combine a CloudWatch Logs metric filter to isolate the data with a CloudWatch anomaly detection alarm. Next, question number 308. Scenario. A media company hosts video files in an Amazon S3 bucket. Users access the videos via a front-end application that provides a temporary authorization token in the URL. An Amazon CloudFront distribution is configured to serve the video files and cache the content. To prevent unauthorized access, the company must validate the authorization token before serving the video. Token validation requires executing a lightweight cryptographic signature check. The validation activity must be logged in Amazon CloudWatch. The company also requires the ability to perform controlled rollouts, such as canary testing, when the token validation code is updated. Which solution meets these requirements with the least operational effort? Options. Option A. Host the token validation code on Amazon EC2 instances behind an application load balancer. Configure CloudFront to route viewer requests to the ALB. Use AWS Code Deploy to perform blue/green deployments of the EC2 instances. Option B. Implement the token check logic using AWS Lambda at Edge configured for origin request events. Attach the Lambda function to the CloudFront distribution. Use AWS Code Pipeline to automate the publication of new Lambda versions. Option C. Implement the token check logic using CloudFront functions. Enable CloudWatch logging for the function. Attach the function to the CloudFront distribution. Use CloudFront continuous deployment to perform controlled rollouts of function updates. Option D. Store the token validation logic in an Amazon DynamoDB table. Use an Amazon API Gateway REST API to evaluate the tokens before redirecting users to CloudFront. Perform rolling updates on the API Gateway deployment stages. The answer here is Option C. Implement the token check logic using CloudFront functions. Enable CloudWatch logging for the function. Attach the function to the CloudFront distribution. Use CloudFront continuous deployment to perform controlled rollouts of function updates. This works because CloudFront functions is designed for lightweight, short-running viewer request processing, such as authorization token validation, header manipulation, and URL rewrites. It executes natively at the edge locations, offering sub-millisecond startup times and lower costs than Lambda at Edge. CloudFront functions natively supports standard console.log statements that are sent to CloudWatch logs. Furthermore, CloudFront continuous deployment allows you to test configuration changes, including function updates, on a percentage of live traffic before rolling out globally, satisfying the canary testing requirement with minimal effort. Let's quickly check the incorrect choices. A. Routing traffic back to EC2 instances behind an ALB defeats the purpose of serving content efficiently from the edge, introduces significant latency, and increases infrastructure management overhead. B. While Lambda at Edge can perform token validation, it is generally heavier, more expensive, and slower than CloudFront functions for simple tasks. Additionally, updating Lambda at Edge requires waiting for the function to replicate globally, whereas CloudFront functions deploy much faster. D. Evaluating tokens via an API Gateway and DynamoDB table introduces substantial latency and architectural complexity compared to performing the evaluation statelessly at the edge. A helpful shortcut is this. For lightweight, latency-sensitive edge compute tasks like JWT/token validation, header manipulation, or redirect logic, prefer CloudFront functions over Lambda at Edge for lower cost, faster execution, and simpler management. Question number 309. Let's go. Next, let's move into permissions boundaries. A company manages multiple AWS accounts in an AWS organization structure. The central DevOps team requires full administrative access to create IAM users with any level of permissions. To improve velocity, developers are granted an IAM role named Manage Users role in their respective accounts, allowing them to create IAM users. However, a new security policy mandates that developers must not be able to create IAM users with excessive privileges, nor should they be able to escalate their own privileges. The central DevOps team must ensure that only they can create IAM users without restrictions. Which combination of actions will enforce these requirements? Choose 2. Choose every option that satisfies the requirement. Option A. Create an IAM permissions boundary policy named Developer Boundary, defining the maximum permissions developers are allowed to grant. Deploy this policy to all member accounts. Option B. Create an SCP at the organization root that explicitly denies the IAM. Create user action unless the AWS principal ARN matches the central DevOps IAM role. Option C. Attach an IAM policy to the Manage Users role that allows the IAM. Create user and IAM. Put user permissions boundary actions, but includes a condition requiring the IAM. permissions boundary condition key to equal the ARN of the developer boundary policy. Option D. Create an AWS config managed rule to evaluate all newly created IAM users and invoke an AWS Systems Manager automation runbook to delete users if they lack a permissions boundary. Option E. Create an IAM policy on the manage users role that grants the IAM. Create user action but denies the IAM. Attach user policy action globally across all organizational units. The correct answers are Option A. Create an IAM permissions boundary policy named Developer Boundary, defining the maximum permissions developers are allowed to grant. Deploy this policy to all member accounts. And Option C. Attach an IAM policy to the manage users role that allows the IAM. Create user and IAM. Put user permissions boundary actions, but includes a condition requiring the IAM. Permissions boundary condition key to equal the ARN of the developer boundary policy. Here's why. To delegate IAM user creation safely, AWS utilizes IAM permissions boundaries. A permissions boundary is a managed policy that sets the maximum permissions an IAM entity can have. To satisfy the requirements, you must deploy the boundary policy, developer boundary, defining the maximum allowed scope, Option A. You must force the developers to attach this boundary whenever they create a new user. This is done by granting IAM. Create user on the developer's role, but adding a condition that the IAM permissions boundary condition key must equal the ARN of the developer boundary policy, Option C. This guarantees developers cannot create highly privileged users or escalate their own privileges. Because the central DevOps team does not have this restrictive condition on their roles, they remain unimpeded. B. An SCP explicitly denying IAM. Create user except for the DevOps role would completely prevent developers from creating users, violating the requirement that developers can create users, albeit with restrictions. D. Using AWS Config and Systems Manager to delete users after creation is a reactive, post-provisioning mechanism. Security controls for IAM privilege escalation should always be proactive and preventive. E. Denying IAM. Attach user policy prevents developers from assigning inline or managed policies to users, but it does not prevent them from adding the newly created user to an existing highly privileged IAM group, thereby bypassing the restriction. Permissions boundaries mitigate this. Here's a useful exam tip. To safely delegate IAM administration, allowing users to create other users/roles without escalating privileges, require the delegating principal to pass a specific permissions boundary condition, IAM, permissions boundary, during the creation API call. Question number 310. Scenario. A development team uses the AWS Cloud Development Kit, AWS CDK, to provision application infrastructure. A DevOps engineer notices that Amazon SQS queues deployed across different CDK stacks frequently lack standard configuration properties, such as dead letter queue settings, and are missing a required organizational cost allocation tag. The DevOps engineer must implement a solution that enforces standard SQS configurations, promotes code reuse, and guarantees that the required tags are applied consistently across all SQS resources generated by the development team. Which approach should the DevOps engineer take to meet these requirements efficiently? Options. Option A. Create a service control policy, SCP, that mandates the cost allocation tag and enforces dead letter queue configurations. Instruct the developers to continue deploying standard AWS CDK SQS constructs. Option B. Create a custom AWS CDK construct that encapsulates the standard SQS queue configuration. Instruct the development team to use this custom construct instead of the default SQS construct. Use AWS CDK aspects to apply the cost allocation tag to the entire CDK app programmatically. Option C. Implement a CloudFormation hook that validates the presence of the cost allocation tag and standard SQS configuration. Deploy the hook across the organization using CloudFormation stack sets. Option D. Create a pre-commit Git hook that scans the developer's CDK source code using regular expressions to ensure the SQS queues define dead letter queues and include the cost allocation tag. The right response is Option B. Create a custom AWS CDK construct that encapsulates the standard SQS queue configuration. Instruct the development team to use this custom construct instead of the default SQS construct. Use AWS CDK aspects to apply the cost allocation tag to the entire CDK app programmatically. This is the best choice because the AWS Cloud Development Kit, AWS CDK, allows organizations to define higher-level abstractions called custom constructs. By creating a custom construct for SQS, the DevOps engineer can bake in default configurations like dead letter queues, retention periods, and encryption. When developers instantiate this custom construct, the standard configurations are guaranteed, promoting code reuse and consistency. Additionally, AWS CDK aspects provide a way to apply operations, like tagging, programmatically to all resources within a given scope, for example, the entire app or specific stacks, ensuring no resources miss the required cost allocation tag. Here's why the alternatives are not suitable. A. An SCP can enforce tags, but it cannot enforce complex resource configurations like dead letter queue architectures natively before deployment, nor does it promote code reuse within the CDK. C. While CloudFormation hooks can validate configurations before provisioning, they do not promote code reuse or simplify the developer experience in CDK. They act only as a blocking guardrail. D. Pre-commit regex hooks are brittle, hard to maintain across complex CDK architectures, which use imperative programming languages, and do not actively apply the tags or configurations for the developer. Exam tip. In AWS CDK environments, use custom constructs to encapsulate and enforce standardized, reusable architectural patterns, and use CDK aspects to apply tags or permissions boundaries globally across all synthesized resources. Question number 311. The focus now shifts to auto-remediation. Here's the scenario. A DevOps team wants to ensure that specific security configurations for AWS resources remain compliant with company policy. If any administrator accidentally misconfigures a resource, for example, exposing an Amazon S3 bucket to the public, the system must automatically revert the configuration change to a secure state without requiring human intervention. Which solution will meet this requirement? The choices are: Option A. Use Amazon CloudWatch alarms to monitor AWS CloudTrail logs for specific API calls. Route the alarm to an Amazon SNS topic that notifies the security team to revert the configuration manually. Option B. Configure AWS config rules to monitor and detect configuration drift. Associate an automatic remediation action with the rules using an AWS Systems Manager automation runbook to revert the non-compliant configuration. Option C. Use AWS Trusted Advisor to continuously monitor the account for security issues. Enable Trusted Advisor automated remediation to apply standard security fixes. Option D. Configure an Amazon Event Bridge rule targeting an AWS Step Function state machine. Configure the state machine to periodically redeploy the baseline AWS CloudFormation templates. In this case, choose Option B. Configure AWS config rules to monitor and detect configuration drift. Associate an automatic remediation action with the rules using an AWS Systems Manager automation runbook to revert the non-compliant configuration. AWS config continuously monitors and records AWS resource configurations. You can use AWS config rules to evaluate resources against desired baselines, such as ensuring S3 buckets are not public. If a resource violates the rule, AWS config flags it as non-compliant. By associating a remediation action with the rule, AWS config can automatically invoke an AWS Systems Manager automation runbook to correct the resource configuration, for example, reapplying block public access settings, without manual human intervention. The remaining options can be eliminated because A. CloudWatch alarms triggering SNS require manual intervention, which violates the requirement for automatic remediation. C. AWS Trusted Advisor identifies security issues and best practice deviations, but it does not provide native, built-in automated remediation execution for all custom organizational security configurations. D. Periodically redeploying CloudFormation templates via step functions is a blunt, disruptive approach that doesn't natively detect when the drift occurred and can cause unintended side effects compared to targeted event-driven remediation. When the exam asks for automated remediation of configuration drift or misconfigured resources, the standard AWS solution is AWS config rules paired with AWS Systems Manager automation runbooks. Question number 312. Let's go. A company operates multiple AWS accounts managed under a single organization in AWS organizations. A recent compliance audit revealed that several VPC security groups were misconfigured to allow unrestricted SSH access, port 22, from the Internet, 0.0.0.0/0. The security team requires a centralized, automated solution to detect and remove these unrestricted SSH rules across all accounts as quickly as possible. Which solution will meet these requirements with the least operational overhead? Option A. Deploy an AWS CloudFormation stack set across all accounts to create an AWS Lambda function. Configure an Amazon Event Bridge rule in each account to trigger the Lambda function every hour to parse security groups and revoke unrestricted SSH access. Option B. Use AWS Systems Manager Run command to execute a custom shell script on all Amazon EC2 instances in the organization to update the host-based firewalls to block port 22 traffic originating from the Internet. Option C. Enable AWS config across all accounts in the organization. Deploy the restricted SSH AWS config managed rule with a configuration change trigger. Configure an automated remediation action utilizing an AWS Systems Manager Automation runbook to remove the non-compliant rule. Option D. Create a service control policy, SCP, at the organization root that denies the EC2. Authorize security group ingress action if the specified port is 22. Wait for developers to manually clean up the existing misconfigured security groups. The best choice is option C. Enable AWS config across all accounts in the organization. Deploy the restricted SSH AWS config managed rule with a configuration change trigger. Configure an automated remediation action utilizing an AWS Systems Manager Automation runbook to remove the non-compliant rule. The main reason is AWS config natively provides a managed rule, restricted SSH, designed specifically to check whether security groups allow unrestricted incoming SSH traffic, port 22, from 0.0.0.0 auth. Setting the trigger to configuration change ensures that the rule evaluates resources immediately when a security group is created or modified. AWS config supports automated remediation via AWS Systems Manager Automation runbooks, such as AWS Disable Public Access for Security Group, which will programmatically strip the non-compliant rule as soon as it is detected across all organization accounts with minimal setup effort. Now let's rule out the other options. A. Writing custom Lambda functions and event bridge rules to parse security groups introduces significant custom development overhead when a fully managed AWS config rule already exists. B. Running a script inside the EC2 instances only updates the host-based firewall, iptables/firewalled, and does not remediate the actual AWS VPC security group misconfiguration. D. An SCP cannot remediate existing misconfigured resources. SCPs prevent future API calls, but the prompt states the security groups are already misconfigured and require rapid cleanup. Keep this point in mind for the exam. 4 common compliance checks, like unrestricted SSH/RDP, unencrypted volumes, or public S3 buckets. Always look for AWS config managed rules paired with SSM automation runbooks before building custom Lambda-based solutions. Next up is question number 313. This question takes us into event-driven automation. A company developed an AWS Lambda function that processes JSON files uploaded to an Amazon S3 bucket. When a file is created or updated, the Lambda function should parse the contents and insert a record into an Amazon DynamoDB table. A DevOps engineer configured the S3 event notification to target the Lambda function. The Lambda function's IAM execution role contains permissions to read from the S3 bucket and write to the DynamoDB table. However, when the engineer uploads a file to the S3 bucket, the Lambda function is not invoked. Which action must the DevOps engineer take to resolve this issue? Choice A. Attach a resource-based policy to the Lambda function that grants the Amazon S3 service principal permission to invoke the function. Choice B. Update the S3 bucket policy to grant the Lambda execution role the S3 invoke function permission. Choice C. Create an Amazon event bridge rule that intercepts S3 object creation events and forwards them to the Lambda function. Choice D. Configure an Amazon simple queue service, Amazon SQS, Q as the S3 event destination and configure the Lambda function to poll the SQ. Go with option A. Attach a resource-based policy to the Lambda function that grants the Amazon S3 service principal permission to invoke the function. Let's look at the reasoning. In AWS, permissions operate on two fronts: identity-based policies and resource-based policies. While the Lambda function's execution role correctly has identity-based permissions to read from S3 and write to DynamoDB, Amazon S3 needs permission to invoke the Lambda function. Because S3 is an external service triggering the function asynchronously, a resource-based IAM policy must be attached to the Lambda function granting the S3 Amazon AWS.com service principal the Lambda invoke function permission. The other choices do not work because B. S3 bucket policies control access to the data stored inside the bucket, for example, who can read or write objects. They do not govern outbound event notifications or grant invocation permissions to downstream services. C. While EventBridge can route S3 events, creating a new event routing layer does not solve the root issue if the Lambda function lacks the resource-based policy to be invoked, and S3 event notifications directly to Lambda is a natively supported pattern. D. Configuring an SQ between S3 and Lambda is a valid architectural pattern for buffering, but it is unnecessary overhead if direct invocation is desired. The core issue remains a missing permissions policy. The main takeaway is when an AWS service, like Amazon S3, API Gateway, or SNS, needs to trigger a Lambda function, the Lambda function must have a resource-based policy granting that specific service principal the Lambda invoke function permission. Next, question number 314. Scenario. A company uses an application load balancer, ALB, to distribute web traffic across Amazon EC2 instances deployed in 3 availability zones. To ensure even traffic distribution, cross-zone load balancing is currently enabled on the ALB target group. The company is rolling out a canary deployment of a new application version strictly to instances in one of the 3 availability zones. During testing, the new version exhibits high latency. The operations team wants to quickly direct all user traffic away from the affected availability zone to maintain static stability while they investigate and roll back the deployment. Which solution provides the most operationally efficient way to shift traffic away from the affected availability zone? Choices. Option A. Remove the subnet corresponding to the affected availability zone from the ALB configuration. Wait for the ALB to deregister the targets. Option B. Keep cross-zone load balancing enabled on the ALB target group. Initiate an Amazon Application Recovery Controller, ARC, zonal shift for the ALB away from the affected availability zone. Option C. Update the auto-scaling group to detach the EC2 instances in the affected availability zone and launch replacement instances in the healthy availability zones. Option D. Keep cross-zone load balancing enabled on the ALB target group. Use an Amazon EventBridge rule to pause the ALB listeners mapped to the affected availability zone. The answer here is option B. Keep cross-zone load balancing enabled on the ALB target group. Initiate an Amazon Application Recovery Controller, ARC, zonal shift for the ALB away from the affected availability zone. This works because Application Recovery Controller zonal shift can shift an application load balancer away from an impaired availability zone. Current ALB zonal shift behavior supports target groups with cross-zone load balancing enabled or disabled. When cross-zone load balancing is enabled, zonal shift removes the affected zonal IP addresses from DNS and blocks traffic from all load balancer nodes to targets in the shifted away availability zone. Therefore, the team can keep cross-zone load balancing enabled and start the zonal shift without reconfiguring the target group first. Let's quickly check the incorrect choices. A. Removing a subnet from an ALB requires modifying the infrastructure configuration, which takes time to propagate and deregister targets. Zonal shift is designed for rapid, temporary operational mitigation without altering the underlying infrastructure template. C. Modifying the auto-scaling group to detach instances and launch replacements takes significant time, instance boot, script execution, health checks, and does not provide the rapid traffic shifting required during an active incident. D. You cannot selectively pause ALB listeners per availability zone using EventBridge. A helpful shortcut is this. For current ALB zonal shift, you do not need to disable cross-zone load balancing first. Arc can shift traffic away from an availability zone with cross-zone load balancing enabled or disabled. Question number 315. Let's go. A large enterprise operates multiple AWS accounts. Each account runs its own Amazon Connect instance. The company uses the default Amazon EventBridge event bus in each account to handle local events. A central DevOps team manages a dedicated observability account. The team needs to aggregate all Amazon Connect events from the member accounts into the default EventBridge event bus in the central DevOps account for centralized monitoring and alerting. Which configuration will satisfy this requirement? Options. Option A. Create an EventBridge rule in the central DevOps account that queries the default event buses in the member accounts for Amazon Connect events. Ensure the DevOps account has cross-account IAM read permissions. Option B. Update the resource-based policy of the default event bus in the central DevOps account to allow events. Put events from the member accounts. In each member account, create an IAM role that permits events. Put events to the central bus, and configure an EventBridge rule in matching Amazon Connect events to target the central bus using that role. Option C. Create an AWS Lambda function in the central DevOps account. Configure the default event bus in each member account to directly invoke the Lambda function when an Amazon Connect event occurs. Option D. Update the resource-based policies of the default event buses in all member accounts to allow the central DevOps account to pull events. Deploy an AWS step functions workflow in the DevOps account to routinely poll the member accounts. Go with option B. Update the resource-based policy of the default event bus in the central DevOps account to allow events. Put events from the member accounts. In each member account, create an IAM role that permits events. Put events to the central bus, and configure an EventBridge rule in matching Amazon Connect events to target the central bus using that role. Here's why. Cross-account EventBridge routing requires the receiving event bus to authorize the sender through a resource-based policy. For new cross-account event bus targets, EventBridge also requires an IAM role on the sending rule. That role grants events. Put events to the destination bus. Each member account therefore filters its Amazon Connect events locally and forwards them to the central default event bus using the target role. A. Event buses are push-based systems. The central account cannot query or pull events from member accounts. The member accounts must actively route, push, the events to the central account. C. A Lambda function in the central account cannot be directly invoked by an event bus in a different account without first routing the event through EventBridge cross-account bus capabilities or managing complex cross-account resource policies on the Lambda function itself. Bus-to-bus routing is the standard pattern. D. Event buses do not support a pull or polling model via step functions natively. Events are published asynchronously. Here's a useful exam tip. For new cross-account EventBridge event bus targets, configure both the destination bus resource policy and a sender-side IAM role that allows events. Put events to the destination bus. Here comes question number 316. The focus now shifts to disaster recovery. Consider this situation. A company hosts its production application in the US East 1 region. The architecture consists of stateless Amazon EC2 instances managed by AWS CloudFormation and an Amazon FSx for NetApp ONTAP file system where all application data is stored. The company must implement a disaster recovery solution in the US West 2 region. A DevOps engineer has already replicated the CloudFormation templates and AMI configurations. The disaster recovery strategy requires the file system data to have a recovery point objective, RPO, of 10 minutes. Which solution will meet the storage disaster recovery requirements? Review the options. Option A. Use AWS Backup to create a cross-region backup plan for the FSx for NetApp ONTAP file system running every 10 minutes. Option B. Configure an AWS Lambda function to mount the FSx file system and use the rsync command to copy data to an Amazon S3 bucket. Enable S3 cross-region replication, CRR, to the disaster recovery region. Option C. Provision an Amazon FSx for NetApp ONTAP instance in the disaster recovery region. Configure a volume-level NetApp snap mirror relationship with a 5-minute schedule to replicate data from the primary region. Option D. Create an Amazon EventBridge scheduled rule running every 10 minutes to take a snapshot of the FSx for NetApp ONTAP file system and automatically copy the snapshot to the disaster recovery region using AWS Systems Manager. right response is option C. Provision an Amazon FSx for NetApp ONTAP instance in the disaster recovery region. Configure a volume-level NetApp SnapMirror relationship with a 5-minute schedule to replicate data from the primary region. This is the best choice because Amazon FSx for NetApp ONTAP natively supports NetApp SnapMirror, a highly efficient replication technology that copies data at the block level between ONTAP file systems. By provisioning an FSx for ONTAP file system in the disaster recovery region and establishing a SnapMirror relationship with a schedule faster than the RPO, for example, 5 minutes, the company ensures the data is continuously and asynchronously replicated. This natively meets the 10-minute RPO requirement without requiring custom scripting or complex backup orchestrations. Here's why the alternatives are not suitable. A. While AWS Backup supports FSx for NetApp ONTAP, scheduling cross-region backups every 10 minutes generates massive API overhead and is not the native, optimized way to replicate active file systems for tight RPOs. SnapMirror is designed exactly for this use case. B. Mounting the file system to a Lambda function to RSYNC data to S3 is an anti-pattern. It introduces massive performance bottlenecks, operational complexity, and cannot reliably guarantee a strict 10-minute RPO for large file systems. D. Taking snapshots and copying them manually via EventBridge and Systems Manager introduces unnecessary custom scripting when SnapMirror provides this capability natively and more efficiently at the storage level. Exam tip. When implementing cross-region disaster recovery for Amazon FSx for NetApp ONTAP, use native NetApp SnapMirror relationships for the lowest RPO and highest operational efficiency. Question number 317. Here's what is happening. A company manages dozens of AWS accounts within an organization in AWS organizations. A DevOps administrator is performing a security review and needs to determine which IAM users and roles generate the highest volume of API calls across all accounts in the organization. The administrator requires a solution that requires minimal setup and avoids managing complex data pipelines or querying infrastructure. Which solution will meet these requirements with the most operational efficiency? The choices are: Option A. Enable IAM Access Analyzer at the organization level. Generate an unused access report to identify which roles and users have the highest activity scores. Option B. Create an organization trail in AWS CloudTrail and configure it to deliver logs to an Amazon CloudWatch Logs log group. Create a CloudWatch Contributor Insights rule targeting the user identity.arn field to automatically identify the most active principals. Option C. Generate an AWS Organizations Service Access Report for all accounts. Write a custom Python script to parse the CSV output and aggregate the last accessed metadata by IAM principal. Option D. Configure AWS CloudTrail to send logs to an Amazon S3 bucket. Provision an Amazon EMR cluster to run Apache Spark jobs nightly to aggregate and query the user identities. In this case, choose option B. Create an organization trail in AWS CloudTrail and configure it to deliver logs to an Amazon CloudWatch Logs log group. Create a CloudWatch Contributor Insights rule targeting the user identity.arn field to automatically identify the most active principals. Amazon CloudWatch Contributor Insights is purpose-built to analyze high cardinality time series data and identify top talkers or top contributors to a specific field. By routing organization-wide CloudTrail logs to CloudWatch logs, a DevOps administrator can quickly configure a Contributor Insights rule filtering on user identity.arn. This natively visualizes the top IAM users and roles generating API calls across the organization with minimal configuration and no complex query management. The remaining options can be eliminated because A. IAM Access Analyzer helps identify resources shared with external entities or in use permissions, but it does not rank IAM principals by total API call volume or activity frequency. C. While an organization's service access report shows the last access date for services, it does not aggregate total API call volume to identify the highest volume, users and roles. D. Exporting logs to S3 and provisioning an Amazon EMR cluster to run Apache Spark jobs requires managing big data infrastructure, writing complex processing jobs, and incurs massive operational overhead compared to the serverless simplicity of Contributor Insights. To identify top contributors, top IP addresses, or most active IAM users from CloudTrail or VPC flow logs with the least effort, Always use Amazon CloudWatch Contributor Insights. Question number 318. Scenario. A healthcare software provider manages a fleet of Amazon EC2 instances running Amazon Linux. To comply with industry regulations, the company must routinely apply operating system security updates, as well as custom application patches. The application patches are hosted in a private custom YUM repository. A DevOps engineer needs to automate the patching process using AWS Systems Manager. The automated process must evaluate and install updates from both the default Amazon Linux repositories and the private custom repository. Which solution will meet these requirements with the least manual effort? Option A. Connect to each EC2 instance and run the yum config manager command to add the custom repository to the /etc/yum.repos.d directory. Use a standard AWS Systems Manager patch baseline to execute the patching. Option B. Use AWS Systems Manager Patch Manager to create a custom patch baseline. Define the source URL and configuration for the custom repository directly within the patch baseline settings. Apply the baseline to the instances using a maintenance window. Option C. Write an AWS Systems Manager automation runbook that first executes a script to download the application patches from Amazon S3, then invokes the AWS Run Patch Baseline document for the OS updates. Option D. Create a secondary patch group specifically for application patches. Deploy an AWS Lambda function that triggers on an event bridge schedule to deploy the patches via SSH before Systems Manager handles the OS patches. The best choice is option B. Use AWS Systems Manager Patch Manager to create a custom patch baseline. Define the source URL and configuration for the custom repository directly within the patch baseline settings. Apply the baseline to the instances using a maintenance window. The main reason is AWS Systems Manager Patch Manager natively supports specifying alternative or custom repositories directly within the patch baseline configuration. By defining the custom application repository in the patch baseline, the Systems Manager agent automatically evaluates and installs patches from both the default Amazon Linux repositories and the custom repository when the AWS Run Patch Baseline document is executed. This eliminates the need to manually log into instances or write custom scripts to register repositories. Now let's rule out the other options. A. Manually running yum config manager on each instance introduces manual operational effort and configuration drift, violating the requirement for the least manual effort and centralized automation. C. Writing custom automation runbooks to download patches from S3 bypasses the native package management capabilities of YUM and the compliance reporting features of Patch Manager. D. Creating separate Lambda functions and relying on SSH to deploy application patches splits the patching workflow, breaks centralized compliance visibility, and adds massive custom automation overhead. Keep this point in mind for the exam. AWS Systems Manager Patch Manager allows you to specify custom repositories directly inside the patch baseline. This ensures that both OS updates and custom application patches can be evaluated and applied simultaneously without modifying instance-level package manager configurations manually. Next, question number 319. Next, let's move into Control Tower. A company uses AWS Control Tower to manage a multi-account environment governed by AWS organizations. The cloud operations team must enforce advanced customizations for new and existing accounts that go beyond the default AWS Control Tower guardrails. Specifically, they need to execute custom configuration scripts in every account whenever an account is provisioned or updated by Account Factory. The team plans to use an Amazon Event Bridge rule in the AWS Control Tower Management account to trigger an AWS Code Build project or AWS Lambda function to apply these customizations across the organization. Which combination of steps is required to implement this automation successfully? Choose 3. More than one answer may be correct. Choices. Option A. Create an IAM role in the AWS Control Tower Management account for the Automation Compute Service, Lambda, or Code Build to assume. Grant this role the STS. Assume role permission targeting the AWS Control Tower execution role in member accounts. Option B. Configure the Amazon Event Bridge rule in the management account to match AWS Control Tower lifecycle events. For example, create managed account, update managed account. Option C. Create a new AWS Control Tower execution IAM role manually in every existing member account and configure its trust policy to allow the automation compute service. Option D. Re-register the organizational units, OUs, or update the existing accounts using the AWS Control Tower console to trigger the lifecycle events for the existing accounts. Option E. Enable AWS CloudTrail organization trails to automatically distribute the custom configuration scripts to the member accounts. Option F. Configure the AWS Control Tower execution IAM role in the member accounts to attach an inline policy that explicitly denies manual configuration changes. The required selections are Option A. Create an IAM role in the AWS Control Tower management account for the automation compute service, Lambda, or code build, to assume. Grant this role the STS. Assume role permission targeting the AWS Control Tower execution role in member accounts. Option B. Configure the Amazon Event Bridge rule in the management account to match AWS Control Tower lifecycle events. For example, create managed account, update managed account, and Option D. Re-register the organizational units, OUs, or update the existing accounts using the AWS Control Tower console to trigger the lifecycle events for the existing accounts. Let's look at the reasoning. Customizing AWS Control Tower environments, often referred to as customizations for Control Tower or CFCT, relies on event-driven architecture. AWS Control Tower emits lifecycle events, like create managed account, to Event Bridge in the management account when accounts are created or updated. Option B. The automation, code build, or Lambda must execute the scripts inside the member account. To do this, the automation runs under an IAM role in the management account that has permission to assume the pre-existing AWS Control Tower execution role deployed by Control Tower in every member account. Option A. To apply the customizations to existing accounts, you must force Control Tower to emit the lifecycle events for them. This is done by re-registering the OU or updating the accounts in the Control Tower console. Option D. The other choices do not work because C. The AWS Control Tower execution role is automatically created by Control Tower in member accounts. Manually creating it is unnecessary and violates managed governance. E. CloudTrail organization trails record API activity. They do not distribute or execute configuration scripts. F. Modifying the AWS Control Tower execution role in member accounts to deny manual changes will break Control Tower's ability to manage the account. The main takeaway is when automating AWS Control Tower baseline customizations, trigger off Event Bridge lifecycle events, create managed account, and use the management account to assume the automatically provisioned AWS Control Tower execution role in the member account. You have completed Set 17 of the DOP-C02, AWS Certified DevOps Engineer Professional Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.